Hello everyone, today let's solve the problem number 53, maximum subarray. So what the question states here, we are given an integer array, you can clearly see here, we are given an integer array nums and we need to find the contiguous or the continuous subarray that has the largest sum and return that sum. When we say contiguous or the continuous subarray, we cannot change the sequence of the elements, right? So this we have to keep in mind, just keep this in mind. We are given an integer array nums and we need to find the contiguous subarray that has the largest sum and return that sum. What is a subarray then? A subarray is a contiguous part of the array, means that we cannot rearrange the elements. So we cannot rearrange the elements. Just keep this in mind. This is very important. We cannot put 4 into some other index just to make that this one largest sum, right? Subarray with the largest sum. So we should not change the sequence of the elements that is present. We have to go with the contiguous subarray, means the elements present in a contiguous way. So that's what we need to keep in mind. So let's come to first example here. We have these elements -2, 1, -3, 4, -2, this one 2, 1, -5 and 4, right? So here the output that we need to return here is 6. Why? The subarray 4, -1, 2 and 1, this one, right? From here to here, this one, these 4 elements. So this one has the largest sum 6. You can just try the sum, right? 4 minus 1 is nothing but 3. 3 plus 2 is 5. 5 plus 1 is 6 here. So the largest, the subarray 4 minus 1, 2 and 1, which has 4 elements, has the largest sum 6 here. That's what they have given here. Same goes with example 2 and 3 as well. We have only one element that leads to output 1. The subarray 1 has the largest sum 1 in this case. And for the example 3, we have here 5, 4, -1, 7 and 8. The output here is 23 because this itself is the largest, this one, the contiguous subarray with the largest sum 23. 5 plus 4 is nothing but 9. 9 minus 1 is 8. 8 plus 8, 16. 16 plus 7 is nothing but, in this case, 23, right? So that's what we need to return, the sum, right? So here I hope the question is completely clear. So first what we will do, initially we will discuss the approach, followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, let's go with the approach. So let's discuss the approach step by step. The first thing we need to keep here in the mind is, we are going with the cadence algorithm. We'll be going with the greedy algorithm plus DP here, right? So we are going with the cadence algorithm. We'll be making use of greedy as well as DP approach, right? So just keep this in mind. I have considered the same example. First example, same example means the first example that they have given in the question, so that it will be easier to understand the approach, right? So the subarray 4 minus 1, 2 and 1 has the largest sum 6 here, right? So we have to return the sum as the output, right? I hope this is clear. So first thing is, we are going with cadence algorithm, nothing but greedy plus DP in this case. Just keep this in mind. So let's see the cadence algorithm implementation along with the greedy plus DP, right? So we are going with the same, this one, array of elements we have here, right? So the first example that we have considered in this case. So why we are making use of cadence algorithm here, or nothing but greedy plus dynamic programming approach here? Because we have to solve this one in big O of n time, right? So optimal solution we get in big O of n. So that is the reason we'll be making use of this one, right? Cadence algorithm here. So we will maintain two variables. One is current sum and the maximum sum. Current sum is the sum of the current subarray. Maximum sum is the maximum found, the maximum sum that is found so far, right? So that is one thing. And one more thing, this is very important, whatever I am saying. So two variables, current sum and maximum sum, we know this is very important. Just keep this in mind, whatever I say now. Current sum, when current sum ever becomes negative, then we will reset that one to 0. If the current sum goes to negative value, then we will reset that one to 0. Why? Because negative sum will decrease the maximum for future subarrays, right? That is the reason we will reset it to 0. again I am telling, we will go with two variables. One is current sum and maximum sum, and current sum, if it becomes negative, we will reset that one to 0. Means since the negative sum will decrease the maximum sum for future subarrays, right? I hope this is clear. Let's see the step by step explanation with the example here. So first, what we have, number, we will consider -2 here. -2. Current sum will be -2 as well. So maximum sum will be here -2 as well. Since the value is negative, as I have said before, we will reset this one to 0. I hope this is clear. Next element we will consider 1. So 1 here, the current sum here is 1 as well. So why here this is 1, not 1 -2, this will become -1. So here we have reset this one to 0. So 0 plus 1 in this case is current sum is 1. So the max sum here will become 1, right? So for the third one, this will be num. Num will be, in this case, we have this one, -3 we are considering, right? So this will be -3. -3 plus 1 here. -3 plus 1 is -2 here, right? Current sum is -2. So again, the max sum will be 1 in this case, right? Why we will consider 1 here? As I have said earlier, we will reset this one to 0, right? 0, and the maximum sum will remain 1 itself in this case, right? So just keep this in mind. We will keep we will reset this one to 0, and the current sum remains from the previous sum 1 itself in this case. Fourth one, we will be considering 4 here. So this one will be 4 plus this one. We will reset the current sum, right? So we will reset the current sum. We will consider only 0 in this case. 4 plus 0, current sum is 0 itself. Since we got this one in negative, this will be 0 itself. So we will, maximum sum is maximum sum that is found so far. I am writing here, so just for the sake. So this one, maximum sum found so far is 1. Sorry, I explained this one wrong. 4 here, this is also 4, and the maximum sum that is found so far is 4 as well. Next we will consider -1 here. -1, so -1 plus 4 here, this will be -3. So maximum sum that is found so far here is 4 as well. Till now this is 4 itself, right? We will reset this one to 0. This we will consider this one as, just give me a second here. Oh, maximum sum, this one -1, and 4, this one has to be +3, not -3. So this one, let me write it 3 here, right? Sorry, this was wrong from my side. So this will be 4 here. Maximum sum that has been found so far, still it is 4 itself, because we have 4 here, right? You can clearly see. And next we will consider 2 here. 2 and 4. We will go with here 2 and 4 in this case. Just give me a second here. 2 and current sum we need to go, right? So I'm getting confused here. 2 and 3. This one, current sum we are going with. This will be 5 in this case, right? So the maximum sum that is found so far is 5 as well. So the next element that is we are considering here is 1. And 1 plus 5 here in this case will be 6. We are going with this. I really got confused here. This is fine. 1 plus 5 will be 6, and the maximum sum that is found so far is 6 in this case. So next element we will consider 5. -5 plus 6, in this case it will be 1, right? -5 plus 6, we have 1. So the maximum will remain 6 itself. Next element we will consider 4. 4 plus 1 here itself 5, and the maximum again it remains 6 itself at the end as well. So the last row, the last value in the maximum sum column, the last value, or the bottom right last value, nothing but 6. This we will return as output, as the maximum sum, right? So this we will return as output. We got 6 here, right? So the output here in this case is 6. right? We got this one from cadence algorithm implementation, greedy plus dp, right? We saw this one. So here the output that they mentioned here for the particular question is also 6, and the output that we got is also 6. So the approach works correct, right? In this case, the approach works absolutely correct. So I hope the approach is completely clear, right? So next what we'll do, let's discuss the edge cases quickly. So the first edge case here is single element array. Single element array, nums of 1 we have here is 1. Nums equals 1 we have, output we have here is 1, right? So here output will be 1, and nums here we have is minus 1, and the output we have here is minus 1 in this case. So we have only 1 here, we have only one element, so output we have here is 1 and minus 1 in this case. So the second edge case we are going with here is all negative numbers we have is 2, minus 3, minus 1, minus 5. In this case we have output of minus 1 as well. I hope this is completely clear, right? So the output that we have here is minus 1. So the third edge case we have here is already maximum subarray. When I say already maximum subarray, we have 5, 4, minus 1, 7 and 8. So here the output will be 23. You can just do it in the same way that I showed for this one, example 1, right? In the approach, if you want to try this, 23. So these are the 3 edge cases that we need to keep in mind: single element array, all negative numbers, and the third one is already maximum subarray, right? Now let's start writing the code. Now let's start writing the code. This will be easy as we have discussed approach clearly, right? So first let's initialize the max sum and current sum. So let's initialize the max sum as first element. Nothing but in this case we have nums. First element means nums of 0, right? So here let's initialize this one, max sum equals nums of 0, and let's initialize the current sum as 0. Current sum to 0 here. I hope this is clear. The next step is we have to iterate through the each number in the nums. We saw that one step-by-step implementation, right? So here the table that we saw. So that's what here we'll go with. Let n of nums. Nothing but we are iterating through the each number in the nums. This one, let current sum equals math.max of n comma current sum plus n here. This is fine. So what we are doing here, we are either starting the new subarray or we are extending the previous one here. So what we are doing here, we are either starting the new subarray or we are extending the previous one. So I hope this is clear. Next step here is max sum. Here we have to update the max sum if current sum is greater. The last table, if you remember, current sum is we saw the current sum at every step, also the max sum that is found so far in the table, right? So this, how can we articulate that one in the form of code? Math.max of, this remains max sum itself, and this will be current sum. This is fine. So just give me a second here. Yeah. So the final step here is we have to return the maximum sum. Let me give here return sum. This is it for the code. So let me format the code once and let the run button. So runtime error we have. Oh, this has to be max. So just give me a second here. Let me hit the run button again. So you can clearly see here the sample test cases are getting passed here. Means let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. In this case, the approach that we went with here is cadence algorithm or greedy with DP, right? So what is the time complexity here? Overall time complexity here is big of n, because we are iterating over nums, every element in the nums. Here you can clearly see. And what will be the space complexity here? Space complexity is big O of 1, because we are making use of only few variables here. You can clearly see max sum, current sum, right? So the overall space complexity would be big O of 1 here. So the time complexity would be big O of n, and the space complexity would be big O of 1 for the code that we have written. I hope the solution or the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.